My name is Don Bowman, my company is Agilicus, and today we're going to talk about protecting critical infrastructure, and specifically I'm going to talk about the intersection set between a technology, Zero Trust Network Architecture, and a set of security frameworks, notably NIST 853 and their Cybersecurity Framework. And what we're going to talk about is sort of how those two things are complementary to each other, how you can use one to support the other, and we'll talk specifically around, in critical infrastructure, some of the gaps that are addressed there. So my name is Don Bowman. I'm the founder and CEO of Agilicus, and this is my passion, Zero Trust. So the agenda today, we're going to talk about, first of all, the concept of control standards and frameworks. And there's quite a few of them out there. And there's every industry, every company has a version of these that would be right for them. The most broadly based one available is the NIST 853 standard, and we'll talk a little bit about it, but we'll also talk about some of the others and how they interrelate. Today I'm not going to really go through the technology. We're going to talk about, at the high level, what Zero Trust is and what its objectives are, but I'm not really going into how it functions today. You can just take my word for it that it functions. For the specific selected cybersecurity frameworks, sort of gasket where they are in sort of maturity level and depth and breadth, and then we'll talk about the specifics of critical infrastructure and how they interrelate. So one of the great things about these controls is there's an awful lot of them. There's one of my favorite XKCD comics, but the idea is you're always trying to create one standard to rule them all, and then you always end up with a lot of competing ones. And there's ones to be chosen that are industry-based. You see like PCI and HIPAA from the payments and medical industries respectively. You see ones that are breadth-based, they try to cover, so many different functions within the company. SOC 1 just covers, finance, SOC 2 just covers delivery. And there's ones that are depth-based. They try to figure out how deep they can go. So today I'm going to talk about how the technical concepts of identity, authentication, authorization, and access support and interact with the National Institute of Standards and Technology 853 framework, because that's the core of Zero Trust. The core of Zero Trust is around who are you, what are you allowed to do, and how do I get you to that thing. And if you want to see a pretty nice laid out model of what these controls are without having to read all the standard, somebody's done a little nice GitHub with that, and there's a little text file that talks about all the different zones and families. So what is the Zero Trust Network Architecture? Like all good things, this also has a set of standards for it, and the National Institute of Standards and Technology in the United States has one, 800-207, and they are very buzzword compliant, evolving cybersecurity paradigms, network perimeters, etc. But I think about it in a much simpler term. Zero Trust is three things. Who is the user? And how strongly do I know who they are? So that's called authentication. What are they allowed to do, and how do I enforce that in some central manner? And how do we get them to that? And this is the key, this last bit, is the concept of a resource on a one-to-one basis. So instead of, imagine an older school company, you showed up at the front door, you signed in the logbook, you wandered on back, 8 hours later you sign out. They have no idea what you did there. You were authorized to do anything. Zero Trust is the opposite, where you're signing into each individual thing every time you use it. So that's really what Zero Trust is all about, is that who, the what, the how. If you have that, you have Zero Trust, and this can be done in a small, medium, or large impact to your organization. It might be just vendors, it might be just privileged systems, etc., but it's going to depend there. So if we go into the why do people deploy a Zero Trust architecture? They do it for a set of reasons that relate to defense in depth. So the idea behind defense in depth is you will be hacked. You may have already been hacked. You might be currently hacked. And you want to slow down the attacker so they can't laterally move through your system. You want to restrict them from doing more and more stuff. You want to show, slow, etc. So this is lowering the blast radius. The next one, and this is how it interrelates to these standards, is auditability. Going back to my analogy of somebody showing up at a company, signing in for the day and signing out at the end of the day, you have a little bit of audit there. You know they were in the building during these hours, but you don't have a lot. You don't know which buildings they went into and what files they looked at. Zero Trust makes more or less a perfect audit trail. Every individual action that is done has an audit event for it. It could be viewing a web page, it could be reading a file, it could be whatever. You got an audit trail, and it's cryptographically proven and attached to the user, so you don't have to worry about lining up IP addresses and times and the time was wrong on that machine. So that's one of the big reasons for the why of Zero Trust, is that perfect fine-grained audit. But another one, a lot of people think about security as denying, let's block that, let's restrict, let's make that harder to do. It actually can be a great enabler. A lot of organizations have really struggled with bring your own device. They say, well, unless I provide it, you can't do anything. And then the users inevitably revolt, and then you end up with a vendor. The vendor works with you, but other people, and they can't really have your device because there'd be 100 laptops on their desks. Zero Trust allows you, because of that pinpoint accuracy, but also that identity of the user being federated to other sources, it can enable these users to do what they need to do. And very specifically that, meeting both your security guidelines, but also their needs. And it can actually be simpler for them. Single sign-on with their existing identity provider, rather than a shared credential from the company that's written in a file somewhere. It also allows you to do like capabilities across unlike things. We're talking about critical infrastructure today. One of the key things in critical infrastructure is called an HMI, a human machine interface. It's usually a touch panel. It's attached to a pedestal, and it tells you how much chemical is going through or what temperature, turns a pump on and off. And these things are a really unholy alliance of deeply embedded systems and IT. So think about them. People think about them as thermostats, but they're actually more like time bombs. They're bolted to your stuff. They got access to everything. They're not really signed in. Zero Trust can allow you to do single sign-on via your Azure Active Directory to an HMI, so you've got that audit trail of who poked their finger on the dump chemical button. Today, the main thing we're focusing on Zero Trust is to simplify the technical controls and audit components of your NIST 853 process. There's a lot of frameworks. XKCD explained that to us earlier. The ones we're talking about today, they fall under the rubric of governance and risk compliance, GRC. And on the left edge of this spectrum are ones that are relatively simple to implement and are designed for specific needs. So the NIST Cybersecurity Framework, this came around in 2013, 2014. It's a pretty good match for companies that aren't really working with top secret or high privacy information, and it's a very good generalist there. So it's good for a certain type of organization. If we move up in terms of how much coverage there is, the next one up would be like SOC 2. We're not talking about that today, but SOC 2 is designed primarily for SaaS companies that are supplying a service to their customers. And then we have what's called the low baseline of NIST 853. 853 is one of the most broad-based standards out there. It covers all industries and all depths. The next one up would be very domain-specific ones like HIPAA and PCI. They cover a very specific set of information and how it's used, but not usually more into the organization. PCI doesn't cover your HR practices, for example. It covers your website with a credit card. The next one up is ISO 27000 family. This is also a pretty broad framework. It's very different from NIST in terms of one is risk-based and one is controls-based. It's an external audit-based versus NIST is not, but it sort of slots in between the low and the moderate baseline. And then down below, in between these, you see some sort of specialized ones that are used for either military applications or what have you. And then you get into the high baseline. When you're in the high baseline, you're dealing with very mission-critical information, very top secret, high privacy, things of that nature that you really can't afford a mistake. There is a right answer here for nearly all organizations. A mid-sized municipality can fit easily into NIST 853 low. A manufacturing plant that has one site could as well. If they have multiple sites around the world, they might choose medium, but they don't have to walk away from the standard because they're the wrong size. at a high-level comparison between these standards and why we've picked this one to talk about today and its intersection with critical infrastructure and zero trust, little quick comparison I put together. So the ISO 27000 family has certification. You go and get certified by a domain-specific auditor. SOC 2 does as well. The NIST standards don't have this property. You can get third parties to attest for you, but there isn't a NIST certification program that they will do for you. The approach is different. The ISO 27000 family focuses on risk management, and the other two focus on technical controls, process controls, people controls. And as a consequence, their principles are different. The ISO 27000 is all around information. SOC 2, some people would describe it as an ethics exam, as these trust services criteria. Are you operating ethically on the data? And then the standards have these control families like access control and so on. And the other thing that varies a little bit is when you use them. So ISO 27000, you're audited right now. Are you compliant this second? SOC 2 is, let's look at your last 6 months of records. And the NIST one is continuous. It's, I'm always doing my controls. You might recall at the low end of that spectrum was the NIST Cybersecurity Framework. Sorry. What they've done there is they've mapped these framework functions to identify, protect, detect, respond, recover, and within each one of those there's a set of controls that you implement. In my opinion, this is a very good general purpose framework. This really fits well for a lot of organizations, particularly if controlling their security is something that's sort of new on their agenda. Today they have a set of processes that are ad hoc and they have policies, and they're looking to put a framework over top of all that. This is a very good way to get started. This came out of a set of US executive orders, specifically around critical infrastructure. So 2013, 2014, and 2017, so two independent US government presidential executive orders, and it's been extended with the current president as well. So it's got a lot of legs underneath it there. Getting into the standard of today that we're talking about, so 853, I'm not going to go into great detail on this. There's others that are far more qualified than I am to do this, but at the highest level, when you pick this standard, you pick your baseline, your low, moderate, or high, and it's going to cover all aspects of your business. You don't get to sort of opt out the recruiting team or the marketing team. It's all of it, and there's not really a compliance audit per se, so you're not gunning for what's the auditor going to ask me, what proof do I have to have. You're doing it yourself. You may use a third party to assist you or to make sure you're honest with yourself, but that's really what you're doing here. And these are the families that they talk about. So access control, awareness and training, audit and accountability. They all give these two-letter acronyms. So you'll see each of these controls will be like AC-4, bracket 4, how to use a inspecting proxy. And then for each of those, you're going to have a little document. And the document says, this is how we do it, this is how we control it, this is how we ensure it, and that's your framework. And the more you go between low, moderate, and high, the more of those you're going to write up, and the more often you're going to check them. So I did an intersection set between the Cybersecurity Framework 853 and Zero Trust, which is a technology. And I'd love to say implement Zero Trust and you're instantly, perfectly, fully compliant to this 853. Unfortunately, I'd be lying to you if I said that. There's two reasons. First of all, you can't really be compliant to the standard because it doesn't have an audit as an approach there. But the second is it's very broad, and Zero Trust is a single technology. It's not a panacea. So I looked at the main family that it applies to, which is access control, AC. And I sort of assessed Zero Trust against three things. Is it the main player? This control, I'm going to be primarily using Zero Trust to achieve the objective, to audit the objective, to control it. Is it a supporting player? I've got a set of policies and procedures in place, and Zero Trust is one of them, and that's how I achieve it. Or is it not really applicable? And interestingly to me, so the majority of them it does have an impact on, but there's quite a number that it doesn't. So in and of itself, you can't say, I've done Zero Trust, therefore I'm ready to call it a day on this cybersecurity framework. But it is a very material impact. But more importantly, while I was doing that, I called it a couple of examples, but there's more than two. Some of the controls, I don't know how you would do without a zero trust framework. I just don't know. They would be very, very difficult. So here's a couple of examples. AC 17.3, which is that access control one, they want you to route all your inbound remote access through a single authorization point. Department of Homeland Security calls this trusted internet connections, or TIC, and they sort of play off that in here. Other people in other industries, they talk about air gap and diodes, etc. But what you're really talking about is you need a choke point where people come in, you figure out who they are, figure out what they're trying to do, you get them to that thing, again, that who, what, how. Without this framework, without this zero trust network architecture in place, this would be a very challenging thing to achieve. I've got a white paper on our website that you're welcome to look at. It explains how to do this in a very industrial context. So ISA, IEC 62443, they call it zones and conduits. But when you look around inside your network, there's going to be something that is industrial. So if you're a municipality, you're going to have a water treatment plant, you're going to have a wastewater treatment plant, you're going to have transportation, they're going to talk about SCADA, they're going to talk about HMIs. That's the standards it comes from. If you are a transportation company, a controls company, nearly everybody who makes something or controls something has these systems, and that's how they implement it. Here's another example. So coming back, if you implement zero trust, you're not immediately instantly compliant to the standard, but some of the things would be very difficult to do without zero trust. Here's another one. So zero trust can be implemented two different ways. It can be a routing architecture, so it's sort of what they call orchestrated VPNs. So you get an IP address that's in the remote site and there's something that controls where it goes to, or it can be what's called a proxy, where things go to one thing and then store and forward onwards. The one that we make here at Agilicus is a proxy-based architecture. It has the ability to do a greater richness of things at a greater cost in CPU performance. The interesting thing about the proxy, it has the principle of intersecting an encrypted flow and providing policy enforcement coupled with identity and resource information there. And that's exactly what the genesis of this control is flow control of encrypted information. They're worried about covert exfiltration. They're worried about somebody accessing a file that's marked as not for you, etc. This is the spot to do it. Without a technology like this in place, this would be harder to achieve. So I guess my conclusions out of that were they're very complementary technologies. So zero trust network architecture materially facilitates getting your technical controls in place for your cybersecurity framework. Your cybersecurity framework materially helps you in understanding the areas you need controls for, and the two play off each other as they go. As I was going through this, I was taking some notes around critical infrastructure. And critical infrastructure, it's kind of the buzzword of today. It's all the things that nobody knows exist in society, but would be very sad if they disappeared for even 1 minute. And I suppose that could be, if you have teenagers, the internet, it could be the water, it could be transportation, it could be wastewater treatment, energy, etc. What's happening here is there's a merger of equals has been occurring at a low and slow speed for the last years. So information technology, when I first started my career, certainly lots of people in the building didn't have computers on their desk, they just had phones. And there were still manual typewriters in use in some places. And today you're on, once a week patch cycle is no longer fast enough, and things are changing very rapidly, and the life cycle of devices has been lowering. So people are 3 years is a long time for someone to own a laptop now. Software is released, every 6 months, every 3 months, every week in some cases. Operational technology is around more of a set it and forget it type environment. I'm going to bolt this pedestal onto this concrete, and I'm going to put this thing in place, and in 20 years I'm going to come back and change it. Those two are colliding. That HMI, that human-machine interface on that pedestal, is now running an embedded version of the same thing in the left column, and it's Windows 7 or Windows XP, and it's not patched because there are no patches, and it originally thought of itself as running in a very trusting universe where the only people that could touch me were physically adjacent, there's access controls to the room, and suddenly they realize that it's not that safe. And you add into that another component, which is what I call the John Deere business model, where the manufacturer says, I won't sell you this unless it's always connected to me. This is part of my service. And suddenly you realize that that thing that you've bought to be bolted down for 20 years that has all the risks associated with the thing you're patching every week, and a third party with a large rotating staff has to be able to get access to it as part of your contract, and you've got a problem. And that crept up on them slowly over time, sort of like the Austin Powers scene with the steamroller, where he's got lots of warning the steamroller's coming at him, and eventually it crushes him. That's what's happening here. The NIST standards, of course, have a standard to cover specific security items to be aware of. They're expanding it. Originally, they covered what are called industrial control systems. This is my little Venn diagram at the bottom here, which is a subset of the entire space, but a pretty decent one. DCS is a distributed control system. SCADA is the supervisory control thing that within there. Building management systems, they kind of half live in and half live without. Every building has these smart thermostats and lighting control, heating controls, door locks, and they're often treated as part of operational technology. But sometimes they're a third team. I recently did a trip to a big industrial plant, and I was very surprised that the building management system was neither owned by the IT team nor by the industrial team, and it kind of was more like HR owned it, and there was trouble. The NIST standards are expanding, so they're no longer just covering industrial control systems. They're calling for input on how to cover operational technology more broadly, and that would be door locks, mechanical systems, time card systems, anything that's outside and around. So what are the drivers for people wondering how to improve security and critical infrastructure? Why am I here talking to you about NIST 853 and Zero Trust and all these acronyms? Lots of reasons, but there's some very concrete ones. The first was the Colonial Pipeline. This was a big wake-up call. So in case you don't remember, a couple years ago, the largest publicly disclosed cyber attack against critical infrastructure in the United States history happened. And this was a big deal. Somebody took down the gasoline supply of a G7 country. It's a big deal. Wars are started over that sort of thing. And what happened was there was a contractor that had shared credentials that got compromised, that had VPN access, and the VPN goes everywhere. Back to that signing into the building, I didn't even know the person that signed in, and I don't even know where they went, and they were able to go everywhere. And then people started to say, well, if it can affect energy, what about water? What about transportation? What about hospitals? This is a big attack. There's a lot of geopolitical stuff going on in the world. There's a lot of actors that have a lot of reasons to get after stuff here. And, they range from commercial crime to cyber, so state actors. Better controls with better enforcement is really the answer to this. So this was one of the big wake-up calls in the last couple of years. The other one was water. This is water treatment plant in Florida, Oldsmar Water. And, the staff, everyone wants to be efficient in their job. So if I tell you there's a plant and it's outside of town and it's hard to get to, and I'm beating you to be very responsive on making sure things are up to date and on time and mean time to repair, you're going to want to be able to do that from your home instead of driving there. So the staff did what you might expect that they shouldn't have done, but aren't surprised that they did do, is they bought this software called TeamViewer, sort of a shared remote desktop. You got a password, everybody can get in, and it kind of sneaks out past your firewall. So it's meant for remote support. So, and they're like, okay, we'll just share the password amongst ourselves. Let's not tell anybody. I got a vendor that supports me. I know that person. They're okay, and this is my team, and we're okay. And when we talk about those human-machine interfaces, in this particular case, it was a Windows 7 machine. I say unpatched, but that's really an irrelevancy. It's long out of support. There are no patches. It has to be always on because it's not a person's desktop. It's a thing. And if you log it out, it stops doing the thing it needs to do, which is controlling the water system. So it's always in, always logged on. It's available over the internet with a shared password. And as you might imagine, something happened to that shared password and somebody obtained access. And the first thing they did is what they shouldn't have done, is they decided to release a bunch of chemicals into the water, in this particular case sodium hydroxide, which would have poisoned people. It would have worn away pipes. The Flint water poisonings, that's because the pipe lining got eaten away and the lead came through. And this is a big deal, right? And it got caught. There are control systems in place that rely on less sophisticated things that are what they call fail safes. They would have probably caught this before people started dying. But it's a big wake-up call. because one of your lines of defense was breached, and they don't really know what happened here. Again, coming back to those executive orders, coming back to those standards, if these people had these controls in place, the team probably wouldn't have done this. If they had, they would have got caught on audit. If they'd had zero trust in place, they wouldn't have had to do this because they would have been able to achieve the objective without skirting it, which is really going back to making security be an enabler rather than a blocker. So what do those two attacks have in common? The first is shared credentials. Shared credentials are terrible, and they're very common. And what happens is, as soon as you say, I work with company X, I know you have shared credentials. You know, our manufacturer, Siemens supports us. How does Siemens get in? They get a VPN. Okay. Is there a Siemens account on the VPN? Yes. How many people work for Siemens? I don't know, 200,000. How many left the company yesterday? I don't know, 1,000. Okay, it's a big rotating pool. How often do you change that password? Change the password what? No, that'd be very difficult because they've got it written down somewhere. You have a problem. So shared credentials is really troublesome. You really want every person signing in with their single sign-on, their Azure Active Directory, their Google G Suite. That way it's attributable to a person, not a company. And you can achieve that. It's called federated identity, and that's what we do for a living. The second thing they had in common was that overbroad, once in, you have access to everything. So their mindset was about access, getting the user in, rather than about zero trust, getting the user to the thing they need, as opposed to the location the thing is in. So if they had implemented the NIST 853 standards, it would have brought this to light, it would have created awareness, it would have created controls, it would have created training, there would have been an audit. These things probably wouldn't have happened. If they had implemented zero trust, they wouldn't have happened either, because they would have had a technology that prevented the attack, they would have had single identity per user, the single resource, and the blast radius would have been reduced, etc. These are complementary things. They could have done either one, or they could do both. It's better if they do both. If they do either one, they're still better ahead. So my conclusion today, before I break for the inevitable complete storm of questions, I think that 853 is a pretty good set of controls for things that intersect with critical infrastructure. That could be the suppliers that work on it. It could be the critical infrastructure itself. And there's a set of standards that attach to it that specify certain things. I think zero trust is a very complementary technology. Excuse me. I think zero trust is a very complementary technology that supports the controls that are in there. Like I said earlier, it's not a panacea. You can't say zero trust on, full compliance achieved, cybersecurity done, but you can say this made it easier, this made it more obvious, it made it easier to audit, it was less cost, it was more convenient. And you can do these in either order, and you can do them incrementally. So zero trust, a lot of people start with vendor access, and they say, we'll just roll this out on that one thing, that one water plant HMI. They're probably thinking maybe I could have rolled it out there. That would have been a good start. Privileged access, these things are the most important, and I need to make sure that only people get there that have the right, and they're only working on the data they have right to. There's no right answer as to how you go first, but I do think these are very complementary technologies. So with that, thank you very much for attending the webinar today on critical infrastructure, zero trust, and NIST 853. And as always, feel free to follow us on the usual social things, our YouTube channel, and thank you very much for your time today, and bye-bye all.